Our next talk is on Lambda fixes, I think, from Lily and Lakshman. Take it away. A reminder before we start. Sorry, I just said that. A reminder before we start. Questions. You probably know this by now. Questions are on the Slido. Please submit your questions on the Slido to bsidessf.org/Q&A, and I will present them to your presenters online. Thank you.
Right. Okay. All right. Hi, everyone. I'm Lily Chau, and I'm here with Lakshmanan Murthy, and we're here to talk to you about the chaos we created at Roku with our WhizBangLambdaFix framework, where AWS Misconfigurations meet our Auto-Fix-It Antics. So, the agenda for today, we'll go over the problem we're trying to solve, the auto-remediation framework, some practical playbooks, and we'll conclude with some metrics. So, we have more visibility than ever into our cloud environments. But what that also means is there are too many findings. Too many findings that aren't critical enough to make it into a JIRA ticket, as well as just too many JIRA tickets. Too many untouched JIRA tickets, as well as too many Slack alerts. Too many unresponded Slack alerts, as well as just too long of a time frame to remediate. With traditional bug fixing via JIRA and Slack, despite all your efforts in diligently writing detailed steps, explaining the vulnerability and the remediation step by step, timely resolution still remains a problem. So one obstacle is time and resource constraints within the teams. So this can impact the quick attention needed to address critical security issues. This is compounded by the lack of security expertise on the developer side, especially with the growing number of AWS services and the possible misconfigurations that it can have. So we recognize a need for change. Security professionals are uniquely positioned to identify, understand, and remediate AWS misconfigurations. Our aim in this talk is to empower security professionals by providing the framework, the playbooks, to safely and effectively mitigate AWS misconfigurations that are impactful to your organization. So not stopping our automation workflows once we file a JIRA ticket, and not stopping once we file a Slack alert, but to go beyond and fix the issue at scale. Okay, so before diving into the solution, let's outline the typical direction of an organization cloud environment. For new services, adopting service mesh architecture for better availability, scalability, security. At Roku, we use Istio. For existing services, migrating them to a service mesh architecture while ensuring uninterrupted service, because business continuity. And then everything else, new and existing, that bypasses service mesh adoption. So this can include spinning up your EC2s manually, containerizing your applications with Docker and Kubernetes, using Lambdas or platform as a service, such as Heroku, to deploy your applications. So while it's technically possible to securely deploy your applications in these non-approved environments, it's uncommon. More often than not, these practices are manual and introduce security vulnerabilities. Now, for your organization, your approved golden standard may not be Istio. It could be a golden image, in which case the direction is still the same. Golden image for new services, migrating existing services to your golden image, and then somehow controlling everything else that's spun outside of the golden image. Okay, so moving on to addressing security in AWS, we'll take a dual approach. Security via secure defaults and guardrails, and security for non-compliant or invariant services. So in part one, on the left, is your perfect dream of security foundations. So you set up organizations with guard duty, CloudTrail, least privilege IAM roles. You set up guardrails with service control policies. And you have thousands of secure by default infrastructure as code, templates, frameworks, and modules, because everything is in the code, any security issues will just be in the code, which you can scan for, block, correct, and even ask AI for a remedial solution. So, okay, wait. Why are people spinning up EC2s manually? So we've heard it all before. I'm new to AWS. I just want to spin up something really quickly for test purposes. I'm more familiar with Docker and Kubernetes. I still don't understand service mesh. Okay, cloud is hard. So if you're going to spin up something in EC2, let's make sure you are doing it securely. So while you learn service mesh and make a plan to migrate to service mesh, let's make sure any of your manual click operations don't introduce vulnerabilities that we can't live with. Okay, so this is the focus of our talk. So the stuff on the right. So auto-remediation against issues introduced by manual actions. Also to secure configurations that we could not secure via SCPs. Because SCPs are not great if you have a lot of edge cases, and SCPs are not great at providing usable error messages. I mean, take a look at this cryptic error message. You are not authorized to perform this operation. I mean, you would never have guessed that what this means is even as an admin, you cannot launch an EC2 that uses the vulnerable IMDSv1 setting.
Hi, let's take a generic workflow diagram how a auto-remediation playbook looks like. So first we start by defining the config policy. Once we define the config policy, we scan for our AWS, we scan for the misconfigurations in the AWS accounts. Now, depending on the risk appetite, now depending on the risk appetite, does the misconfiguration need approval from the owner? If not, just fix it, tag it, and record it, just in case we need to roll back. So if the misconfiguration needs approval from the owner, we send them a Slack message asking them to review and fix the misconfiguration. Because if not, you have two options. They can either apply for a 1-month exception, or they do nothing in 48 hours, we go and fix it. Now, if the misconfiguration is in a production account, since we don't want to touch production accounts, we send a Slack message with 3 options. Apply for a 1-month exception, apply for a 1-year exception, or do nothing, ignore the Slack message, and your misconfiguration will be auto-remediated in 48 hours. The whole workflow is performed just by Lambdas, and each remediation workflow itself is our own Lambda. In addition to our goal of no Jira, we also have a goal of no Slack. We don't want to bombard users with millions of misconfiguration messages per misconfiguration. So we use Slack messages to very minimal when we tune out the false positive in the initial stages. So before jumping into the architecture, we need 2 basic IAM roles in every AWS account that we intended to perform run the playbooks. So as standard, the first one is the security auditor IAM role with the security audit permissions, which gives read-only permissions for all AWS configurations. And this role can be assumed only by the AWS security account. Similarly, we require a second IAM role, which allows the security team to tag the misconfigured resources in any AWS account that the organization uses. So why we use tagging? So tagging easily help us to track resources. As well, we follow a strict tagging policy in our organization. For example, Roku security prefix is only allocated to the security team. This allows. So this is because we don't overwrite any user tags, as well as the users can know who applied these tags. Another use case for tagging is the ownership tagging. We can use CloudTrail logs to pass for the owners based on the create related events in the CloudTrail logs, and then we can fetch the email addresses from there, and then we tag it to the resource. So this helps us quickly track the resource owners in case of an incident. So we have two types of remediation. One is scheduled remediation that happens daily at a fixed point of time, and then we have real-time remediation. First, let's take a look at the scheduled remediation. So as I said before, each misconfiguration playbook is itself as a Lambda. So the Lambda iterates through the list of active AWS accounts and the list of active regions for that account. Next, we iterate through the targeted misconfigured resource. So when we find a misconfiguration, the Lambda assumes a third IAM role that has the permission to remediate the misconfigured resource in the targeted AWS account. So some example for scheduled auto-remediation includes deleting elastic IPs that are not in use, deleting unused EBS volumes, updating EC2s over to use IMDS v2 over IMDS v1. Note this architecture is very bad, no event bridge, no CloudWatch, no SNS, no SQS. This is because the misconfigurations we are trying to fix here are not that critical. We can wait for 24 hours. So we can get rid of any components that may incur additional cost. So next, we have real-time remediation. It's almost the same as scheduled remediation. The only difference is the component of the left, which has CloudTrail involved. So we have separate AWS account at Roku for centralized CloudTrail logging from all the member accounts in the organization. Then we configure event bridge to ingest these logs. Next, we create multiple filters based on the specific events depending on those events and invoke the appropriate Lambda. So some example for real-time remediation includes manual creation of EC2s, in production accounts, manual creation of IAM user and manual deletion of EBS environments. This just let us know IAC coding practices were not used. So let's take a deep dive into the one scheduled remediation playbook. In this playbook, we are trying to find the unused EBS volumes that are not associated to an EC2 instances for the last 45 days. That means that EBS volumes are just sitting idle and no one is using it. So first, we start by scanning for EBS volumes in the all active AWS accounts, and then we look at existing tags to see if the last seen tags are present. If not, this tells us the playbook is looking at the EBS volume for the first time. If the tags are not present, we add an invariant tag to define which auto-remediation playbook is this, and then we also create a last seen with our current timestamp. So next we look for any exception tags. So we define it as security EBS allow list equal to true. If those tags are present, it means the resource owner acknowledged us that EBS is in use, so we can end the workflow there. If not, we have to parse the CloudTrail logs for attached, detached volume events. So in scheduled remediation, we are not looking at the resource continuously. We are looking at the resource at a single point of time every 24 hours. So the resource can be used in the past 24 hours, and the playbook doesn't have visibility to it. So by analyzing the CloudTrail logs, we can take a correct decision that if this EBS volume is used. So if the volume has attached, detached events, we just update the last seen tag. And then if it's not, we'll check if the last seen tag is older than 45 days. If it's older than 45 days, we can delete it, and then we store the logs and we send notification email to the admins.
Okay, so let's go through how we are detecting manual actions outside of approved infrastructure as code workflows. So previously, we used to analyze the user agent to infer from the CloudTrail logs whether the event was a manual action. Now, we kind of look at events initiated by employees. That's where the role session name ends with @roku.com, because then we know there is a responsible user making the alert actionable. We also look at the CloudTrail event to see if it has the read-only flag set. So that means the event is a mutating action or a create, update, delete type of event, which is much better than thinking of what to filter out of the list, get, describe type of actions. Hey, so let's go through an example of how we would quarantine an EC2 that is created manually. First, we create an event bridge filter to capture the run instances event in CloudTrail. We then filter for the user identity to know who spun up the EC2. We create a threshold of 5 EC2s spun up by the same user within a 15-minute time frame. If this threshold is exceeded, we terminate the workflow. Otherwise, we invoke the EC2 quarantine Lambda playbook. The playbook involves tagging the EC2 as invariant, and then quarantining the EC2 via restricting ingress traffic via security groups and attaching an IAM policy to deny access to AWS resources. After 1 month, if it still exists, we delete the instance. Now, the reason why we have the 15-minute time frame is because we've had cases where a user was using a Python script on their laptop, using their SSO credentials to bulk spin up EC2s for 1 minute of data processing before deleting them. So even though this is technically a manual action, they have a common way of deployment. But if they introduce other security vulnerabilities we can't live with, we will deal with those with other Lambda playbooks. Okay, so let's go through how we would perform residual remediation after deleting an S3 bucket manually. So this is a sign of bad cleanup and release management. So first, we create an event bridge filter to filter for the delete bucket event. If the event is detected, we invoke the S3 subdomain takeover Lambda playbook. So the playbook first involves formulating all the possible domain names that bucket can have. So if my bucket is named foo, then your possible domain names could be foo.s3.amazonaws.com, foo.s3.region.amazonaws.com, and foo.s3-website-region.amazonaws.com. So now that we know all those domain names, we need to check both Route 53 CNAMEs and the list of CloudFront distributions to see if it matches. If so, we delete them. Now, if your S3 bucket has a domain that is centrally managed via IAC, we need to extend our remediation efforts to the code repository. So this playbook is blurred between the secure default track and the manual remediation track. So our Route 53 adheres to the principle of secure default, where to ensure there's no drift between the code Route 53 and the cloud Route 53. So if someone manually deletes an Route 53 record, it will just fix itself. But if it's the resource that is being deleted, in this case, the S3 bucket, we cannot perform a CLI-based fix because your subdomain takeover vulnerability would just keep reopening up. So we have to apply a Terraform fix. So same thing with an ELB deletion. So I'll just go through the possible domain names that you may not be aware of. So if your load balancer is named foo, you have 3 possible domain name combinations. So foo.elb.amazonaws.com, foo.region.elb.amazonaws.com, and dualstack.foo.elb.amazon.aws.com. So the dual stack means your load balancer supports IPv6. Otherwise, same, still need to check Route 53, CloudFront, and apply or fix Terraform, CLI, depending on your company. So if you want to solve for your subdomain takeover completely, we need to follow this same remediation playbook for other resources such as Elastic IPs, CloudFront distribution, API gateways, and Elastic Beanstalk. Okay, so let's walk through how we would reduce lateral movement. So first, we need to create IAM mappings between a principal and a resource. So a principal can be an IAM user, role, or user group. A resource can be another IAM user, or it could be an EC2, EKS, or a Lambda. So every time you see a principal with admin IAM permissions over a resource, you create a mapping. Every time you see a principal with impersonate permissions to a resource, create a mapping. You are now able to chain these mappings to detect lateral movement. So this could be an EC2 is associated with an IAM that points to another IAM, which points to another IAM, which points to another IAM with admin IAM permissions. So when I say admin IAM permissions, what I mean is create user, create policy, wildcard IAM permissions. So as you can kind of guess, a resource such as an EC2 has no legitimate reason to create an IAM user. Okay, so for remediation, let's pull all of these resources with admin IAM permissions and pull all the resources that are chained to have admin IAM permissions. You can do this for 2, 3, 10 hops. And let's double check in IAM Access Analyzer or CloudTrail if those IAM and impersonate permissions are actually legitimately used within the last year. If not, we create a new IAM policy with all the permissions stripped out, attach the new policy, detach the old policy. And you can do this for any IAM permissions. So as we scale up to a large number of Lambda playbooks, managing them can get out of hand. And you may have observed there are certain recurring modules within these playbooks. So this is where you can consider wrapping your playbooks within Argo workflows or any orchestration tool to just ingest your misconfiguration and just boom, 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 remediate. Okay, so you may be thinking, how is this different to AWS Config? So Config is a service that keeps track of your configuration or your metadata of your AWS resources. It has a predefined list of config rules to check against, but it also provides a means to remediate via AWS Systems Manager documents or SSM documents. To reiterate our point at the beginning, ideally you should have no use for config and you should instead use infrastructure as code. If you are using IAC, you know the resources that are being managed and can correct the configuration for. And if you need to do configuration tracking, you can do it much more cheaply with EventBridge instead of config. But let's learn from our mistake and go through some of the pain points that we saw. So data loss. So we've had many missed configurations because of config. So config uses a lot of API calls for all our rules against those resources, that it actually impacts some of your more business critical API requests from working. And if you have your remediation playbooks, you need to make sure you deploy to all regions for all accounts if you don't want to miss anything. And costs. So the cost is way too high for just logging configuration changes. So note I said configuration changes and not logging actions or events that are more useful for incident response type scenarios. Config is also prone to cost spikes in the event of restart loops or if your deployment method involves a lot of creating, recreating, and deleting resources. You may also be thinking, how is this different to Cloud Custodian? So actually, our framework similar to Cloud Custodian config and even Twilio's sockless operates on the same principle. It's just the remediation playbooks is defined in a different format, whether it's a YAML file, SSM document, or some other wrapper file format. The key difference between us and the other frameworks is in the playbooks. Okay, so let's say you buy a cloud tool. You get millions of findings, but then you get stuck. What do I remediate? What do I remediate that will actually make a significant impact? And then you start to notice that the only thing people fix and the only thing that people jump up and down about are public S3 buckets. So you basically bought a tool to fix public S3 buckets. I mean, it's the same thing with buying a SOAR or some orchestration tool. What did you do with it? Phishing. The only thing you automated is phishing? Okay, so then the other problem is we don't know what to fix. We just don't know how to prioritize. And when we do know how to prioritize, we know how to fix it for one system, but not necessarily systemically for the whole organization. So this is where we come in. So I'm going to list out exactly what you can remediate that will make an impact, and this revolves around cost optimization, minimizing attack surface, and reducing the blast radius. So I've broken the list of playbooks into different categories. So depending on your security maturity, you can implement them all, start from the basics, just pick and choose based on the needs of your company. Okay, so let's go through some, not all, of the security configurations that would make an impact. So anything related to IMDS v1. So in your EC2s, autoscaling groups, AMIs, EKS. So this is the single best thing you can do to reduce SSRF attacks. Note that AWS now defaults to IMDS v2 for new instances, so it's important to clean up your tech debt now. For Route 53, if the only records you have for a subdomain are NS records, nothing else, no TXT records, no CNAMEs, no A records, just delete the whole thing. So this mitigates the risk of a future DNS zone takeover. To save costs, okay. Anything you can do with RDS is the biggest cost saving you can do. So if there's no connections within 45 days, delete it. Okay, realistically, if people are keeping it around for storage, they don't need to make a connection. So DB snapshot it, delete the database, and if the snapshot is not used within a year, delete the snapshot. Same thing with Redshift and stopped EC2s, snapshot and delete in 4 to 5 days, and delete the snapshot if it's not used within a year. For anything unassociated, such as Elastic IPs, load balancer, EBS, delete it. For EC2s that are underutilized, it's a little hard, so for newly launched EC2s, we'll enable CloudWatch metrics, analyze the CPU usage is less than 10%, and the network I/O is less than 5 megabytes over the course of 45 days. And if that's the case, we'll delete it because it was probably forgotten. Now, for existing EC2s, it's still hard to tell if it's needed. It may be running a cron job requiring no user connection. So for existing EC2s, it's safer to just snapshot and relaunch on a more optimized instance type, which AWS luckily gives us a recommendation for. Threat detection. So we always have a possibility for false positives, so we want to make sure we require Slack user responses. Some high signal, low noise things you can detect are Cloud Shell. So if someone is downloading secrets, more likely than not, it's an attacker. Honeypots, in our cloud environment, we sprinkle AWS keys everywhere, so when they are triggered, it's probably because it's a human, so quarantine the EC2, the IAM. Now, for your indicators of compromise for threat detection, they can quickly go out of date, so it's important to focus on the attacker tactics that cause the most damage, such as credential exfiltration. Attack surface, we went through this with lateral movement. Standards, so if you have a tagging standard or are mature enough to enforce a tagging standard, including for public resources, remediate if they deviate. Invariance, if you are further along with your infrastructure's code enforcement, then control any sort of your manual create and delete events. Metrics. Okay, so what I want you to get out of this slide is while we are trying to remediate some things like IMDSV1, we notice a lot of deployment methods. So fixing IMDSV1 via CLI will solve 43% of issues, whereas CloudFormation is 50, Terraform 2. So make sure you are targeting your remediation playbooks on the deployment methods that your company uses the most. But in the case of Terraform, so you should note that 2% may not seem like a big number, but it was just the one change that affected a large number of clusters all at once. That's a good thing about golden standards. So in terms of costs, the biggest monthly cost savings was for RDS, and we had 33% of our databases being idle. Note that some of these databases only saved us $12, whereas others were $2K a month. Your actual savings may vary, but note that we saved this number even though we had a dedicated cloud financial operations engineer on the team. Let's compare this cost to how config cost us, which was $50K month over month. And as you see, as time goes by, even if you reduce your attack surface, you'll see diminishing costs as the attack surface decreases. And this is in comparison to Lambda, which was consistently just costing us $1 a month. Okay, challenges. Company buy-in is hard, but we'll skip over that. So prevention and balancing prevention versus remediation. Okay, prevention is the only thing you can do to significantly improve the difference between your huge attack surface and your small remediation capacity. And one day, remediation shouldn't fire unless something goes really, really wrong. Lessons learned. So tagging is our unsung hero. By tagging something and then looking for it at the Cost Explorer, we are able to estimate the savings of our remediation efforts. And when it comes to remediation, keep a close eye on surges because they tell us to reassess our remediation strategies because maybe they're getting rolled back for whatever reason, or someone is persisting in spinning up a non-compliant resource. And finally, even something as universal as encryption and TLS standards, there are still edge cases. Future work, AI, please. In summary, you can do this. You can remediate. You have the framework, you have the playbooks, so don't stop your automation at Jira and don't stop at Slack. Go beyond and actually fix the issue. But first, solve as many problems as you can with secure defaults and then focus on remediating invariants to those defaults. And don't feel bound by AWS built-in services. Config is expensive. And just know that we can't fix everything. Bugs will always exist. And with that, as they say in the movies, it's time to fade to black. Unless it's a PowerPoint, I'm going to click and show.
Okay, thank you so much. We have a few questions here on the Slido. I note that we are at time, but it's a 30-minute break before the next session, so we can use that time to take some questions. So I will share them. First question, what was your biggest pain in using SCP?
So SCPs, yes, the biggest one is usable error messages. So like you think SCP is going to solve all your problems, but then when the user tries to spin up something, it's like, how can we even format it so that they can be more usable, but there's no way at this moment. What else? Oh, and so SCPs are not great if you have a lot of edge cases. So if this one account needs this one region, you can't really use SCPs. It's like an all or nothing. So if you have edge cases and ideally you want to tag and say, I want to exclude this edge case, you can't. It's an all or nothing.
Cool. Next question, do you limit and control egress traffic as well?
Yeah.
Yes.
Yes.
Yes, and we do that via security groups. And we, as a double measure, will attach an IAM policy to ensure it doesn't talk to any other AWS services.
And finally, did you encounter many instances where auto-applying a fix broke a service? And how confident would you be doing this in production without manual review and approval? All these questions were anonymous, by the way. That was a good one.
I know I was kind of willy-nilly when I say delete this, delete that, but that was actually not the case. So all of these remediation playbooks took like, each one was like 6 months to a year each. So, it's first we're saying, okay, company, we are now enforcing this new standard. So whatever compliance thing, you can't do this anymore. We then send them a list of all the resources that are non-compliant. You need to review this. Otherwise, we're going to fix this ourselves. And then, we send weekly emails. There's a reminder to say, hey, this is coming up. Your thing is going to be fixed. So please check because there may be false positives. And then even during the day of the auto-remediation, we don't even fix all of it, only for dev, because as you kind of guess, production is not great. So we say we're going to fix, but we don't touch production. And we need to constantly just hound and be like, hey, please review, is it okay? So each of these playbooks was just like that. And eventually you get to a stage like, okay, we didn't break anything, and you can trust us to continue to do more remediation.
All right. Thank you very, very much. Hey. Lily and Lakshmanan, thank you so much for this talk. Really appreciate it. Big thanks to our sponsors, especially Socket Security, who has donated these very nice speaker gifts.